Hello, you're watching Everard Junction, and today is another part on the building model railway series. Today I hope to have a train running through these sidings, make sure everything works. So in order to do that, I'm going to need to run the electrics and get some of the point motors in, and basically wire the thing up. Now it's a DCC layout, so all the tracks are going to need power, so I'm going to have to run a set of dropper wires to all of the tracks, and that includes these two over here, that one, all the lengths of sidings down here, and any bits of track that creep up between the points. I'll put a set of droppers in there as well. So the aim is to get electricity flowing to all parts of the yard. Okay, so in order to get the electricity flowing to all of the tracks, I'm going to need what's called a bus wire, and that is a pair of wires that runs underneath the baseboard that I can tap into to get electricity. It's just a way of saving huge lengths of wire. So you imagine these two wires underneath the baseboard, they run down the middle somewhere. If I drill two holes on this piece of track and run some dropper wires to it, the dropper wires are only going to have to be that long, and they can just tap in to the electricity supply I've got running below the baseboard, rather than having to route every set of wires back to the controller. So here's my set of bus wires, and this brings me on to probably one of the most frequently asked questions I get, and that is, what type of wire do you use for the bus wire? I've been asked that loads and loads of times. And it's quite a simple answer, and I'll show you what it is. This is what I use. This is 2-core household cable. You get it in rolls from most DIY shops, and you use it to wire up your house. You use it for lighting and various other things. You can get it in solid core or other varieties, and you can see inside the white insulation you have your two chunky wires. So what I did years ago is I got a roll of it, strip off the white insulation, and you're left with a big bundle of nice heavy-duty cable that you can use for the model railway. So that's what I'll be using. I'll be running them underneath the baseboard. I can't tell you what size they are because I don't know. They're just whatever the size is that you rip out of that household cabling. I find it to be the perfect size for tapping into with those plastic connectors that I use, which you'll see more of later. So here we are underneath the table, and you can see the bus wires that I've got running for the layout. I employ up to 3 sets of bus wires. One of them runs the signalling, one of them runs all the point motors and the lighting accessories, and the other one is just the power for the track. And actually that also is used for the polarity switches on the point motors. So what I'm going to do, I'm going to tap into this, and we're just going to run another bus. It's just going to go up and along there to the end. And that should give me everything I need. Okay, so got one of the bus wires, and all I'm going to do for this is just put a spade connector on the end of them and then tap them into one of those connectors. It's quite a short run, and those connectors have served me extremely well over the last 4 to 5 years, so we shouldn't have any problems. It just makes it a little bit easier than using a chocolate block. I'm just going to put a bit of flux on the cable, and we'll put some inside the connector. Okay, so I've clipped in some splicers into the bus wire for the track, which is hidden behind that beam. I use these crimp blade splicers quite a lot, and the part number for those is 330190, and as usual I get it all from Rapid Electronics. So now I just need to find a way to tidy the bus wires up to the top of the baseboard. I've got some clips for that, and then I can clip in the bus wires and we can start soldering the droppers. These are the cable clips. I got these from a DIY shop years ago. Just sort of generic sort of cable tidies, very useful. So I'll screw some of those to the support beams that run underneath, and then thread the wire through. Okay, so I've run the bus wire, or bus wires, go through the clips, and then you can just see the connectors at the end where they tie in to the main bus wire on the rest of the layout. So the next job is to find a spot where I'm going to put the dropper wires for each track and drill all the holes for those. Okay, drilled all the holes and inserted the dropper wires. So what I'll do now is I'll solder them to their adjacent rails, and then underneath we can hook it up to the bus wires. Only thing you need to be careful with is making sure that you get the wires hooked up correctly. So for example, the rails on each piece of track nearest to us, they all need to be connected to the same wire, and then the ones furthest away, they all need to be connected to the other wire. If you mix and match which side goes where, you'll end up with a short circuit. But we'll cover that in more detail in a minute when I've soldered all of this lot. Okay, I've soldered in all of the dropper wires. You can see some there, 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 and then they run up and stay in line with each other. So the next thing to do is to connect them to the bus wires. Now it's important you get them the right way round. On my layout, this rail here is negative, this rail here is positive. If you're building a layout from scratch, it doesn't matter which way around you put it. Once you've chosen which rail is positive and which rail is negative, you need to stick to it. Because let's say, for example, this rail's negative here. If I was to then wire that one to a positive bus wire, I would short the entire layout out and nothing would work, and you'd be sat there scratching your head, chasing bus wires, trying to work out which one you've done wrong. So do try to make sure that you wire them up correctly. So there we go, dropper wires are in. I've made sure to get the rail that's closest to this side of the table going to negative, and the rail that's further away to positive. And I've mirrored that for all the lines. So now it's ready to turn on the layout's power and see if we have any problems. Okay, so I've turned on the power to the controller, and it's sitting on the Class 08, which is good, means there's no short circuits. I should test actually that it still works if a short circuit occurs. It's very useful for safety if you have a derailment, or if there is a wiring issue that the system just cuts off. So that's there you go, shorts out straight away. Cool. So remove that and reset. Let's see if we can move something. There you go, excellent. So that is the first train officially running on the new section. Okay, so before I go any further, I'm going to do a full test of every single siding and length of track and see if there are any problems. Now, the points aren't wired up yet, they're just relying on the blades for continuity, and some of these points are reused. So there could be some issues with the points, because as I say, they're not wired up with the point motors yet. But the theory goes, if it's all clean, it should all work. So I'll test everything and see what happens. So far it's all looking quite successful. These reused points are all weathered, so they don't work very well conventionally, and also the freeway point will need wiring up. This whole area of the freeway point is dead until it's wired up correctly, so I'm expecting it to stop there. I've just got this one here to test, and then we can call all of the lines working. A few alterations to do. I've noticed there's a slight kink on this middle track here. It's ever so slight, but it was noticeable when the 08 went over it. It also helps if you change the point. KD's got stuck a little bit there. Get him. There we go. So this line's working as well. Excellent. Okay, so I've done a little bit more testing, pretty happy with everything, so now we move on to installing the point motors. Now, wiring these is going to be a little more complex than a sort of conventional Insulfrog point, because I do use the Electrofrog points for better reliability and a more prototypical look. I've done a video in the past that goes into a lot of detail on wiring up an Electrofrog point with a SEEP point motor. I'll be going over most of the core principles and showing you what I'm doing, but it won't be as in-depth as that video. So if you still have questions or queries, go and check out the how-to series and find the one that's called Fitting a Point Motor, and that'll give you some more information. Electrofrog points work with this cable here that's attached to the bottom of the frog. That's fed from the point motor, and it supplies the point with continuous power, and that means that you don't have to rely on the switch blades making contact to get the electricity to flow. So these can get as dirty as you like, and you can even weather them if you want to, and they have no effect on the point's operation because it is independently powered using this cable. I've got two different types of point motors. Today I'm going to be using the SEEPs, but I also have some Pico ones with a polarity switch as well, which I'm just trying out. Never actually used them before. Loads of people use them and they look pretty good, and they were on offer on Hattons in a bundle, so I've got some of those as well that I'm going to be putting in, but for now I'm going to use up my supply of SEEP motors. They both do the same job. They both switch the point, and they both have a polarity switch. The Pico one is an external unit that you have to buy separately. On the SEEP it's built in, but they do the same job. When you throw the point, it sends either positive or negative, whichever's required, to the point, making sure that you have continuous power. I'll also be wiring the freeway point, as I know a lot of you want to see that. The wiring for it is somewhat more complicated, but now I actually have a set of instructions. I can remember how I did the previous one. So I'll get that wired up. It's not too bad, you just have to treat it as two separate points, because in effect it is two separate points. The only tricky bit is wiring the polarity switches. You have to wire them together in a certain way, but we'll go over that when we come to it. Okay, so before I start wiring up the seat motors, I'll just quickly run through what goes where. Now, the motor has 6 outputs on it. 3 of them make it move points, and the other 3 make sure that power is sent to the point. So your switching side, the bit that makes the point motor actually move backwards and forwards, is terminals A, B and C. A goes to one side of your switch, B goes to the other side to throw it the other way, and then C goes to a central earth. The DCC side of things is terminals D, E and F. D is, it can be either way around, but D, let's say in this example, it's the plus for the DCC. E is the minus for the DCC, and then F is what goes to the frog. So when the motor moves left or right, the polarity switch will get activated, and it'll either connect terminals D to F and send positive to the frog, or if it's gone the other way, it'll connect E to F and send negative to the frog. And that's how you don't get a short circuit when you switch the points, because the polarity switch always makes sure that the right voltage is sent at the right time. However, it is important that you make sure your motor is in the correct orientation. If you put it in the wrong way around by accident, you'll end up with plus getting sent to the frog when actually you need minus, but don't worry about that. The switches I use are single pole double throw with a sprung centre off. That means they spring back to the middle and don't do anything, and they only work momentarily when you pull them one way or the other. So what I'll be doing is I'll be connecting A to one side of it, B to the other side of it, and then the middle one will go to a positive 12 volts from my DC controller. That's that other set of bus wires that I use for just working the points and accessories, which is 100% DC. So when you throw this switch, whether it be left or right, it'll bridge the middle terminal to either one of the outers. When it does that, it completes a circuit, and you end up with 12 volts flowing through the switch, going into one of the output terminals, and that will then flow to one side of the point motor, and that will shunt it one way or the other. The point motor is earthed at point C, so you have 12 volts coming into your switch, you've pulled it, it goes into the output terminal, comes along, goes into the point motor, it flows through the coil of the point motor, and it then goes through terminal C and back to earth, which completes your circuit, which will throw this motor whether it be right or left. And that's roughly how it works. That's how you'll wire up all point motors. The only difference with these ones is they have the polarity switch, so I also have D, E and F to worry about, and all that is basically the same kind of deal. Inside is a switch working similar manner to this, and it will just connect the DCC plus to the frog or the DCC minus to the frog, depending on which way the point has been thrown. So I hope that makes sense, and I'll now wire one of them up. So there we go, they're all wired up. So we have switch, earth, dropper wires for DCC, feed to the frog, and then the switch again. Okay, so the next job is to run the bus wires I'm going to need to control the motor in the switch, and that bus wire is my 12 volt accessory bus wire that I use for layout lighting and anything that's just ordinary DC. That bus wire is currently sitting there. I need to tie it up at the moment. It's a bit loose while I was installing the new baseboard. But I'll get same deal, just splice the wires into there, run them through the cable tidies, and then I have everything I need to connect up the point motors. Okay, I've run the DC bus wires, which I can use for the point motor power. So now I'm going to wire up the rest of the point motors and get as many of them wired in to save some time. Okay, I've wired up 6 seeps, all ready to go. Holes for all the point motors are already drilled, so it's just a case of putting them underneath and securing them in. One thing with these seeps is you really need to be very sure that when you put them underneath the track that they are in perfect alignment with the direction that they're going to throw the point. So for example, let's get this one. When you put it underneath, you want it to be as close like that as possible. If it's like that, it won't work. It'll really struggle to throw the point. You need to be absolutely sure that you're in perfect line with the tie bar of the point so that it works nice and smoothly. You also need to watch for the alignment of the polarity switch. So when you put it underneath, you need to make sure that when the point throws, it does move the switch either way, so that it's going to be able to make contact on each side of the motor. If you end up with it sitting at rest in the middle and then when it's thrown one way it's all the way over here, it's not going to work properly. So you just need to take a bit of time and make sure that they're in the right place. And I'm sure the same goes for any other type of point motor. The position is key. Okay, the first motor is secured underneath the freeway point. There'll be another motor going just there. But you can see what I mean about how crucial it is getting everything lined up properly with the polarity switch. So if I flick the point, you can see that spring piece of metal is getting right to the ends on both throws of the point. And it's crucial you get that right, because if it's off and it sits somewhere funny like that, then you won't get the power flowing to the point and your locos will stall. Okay, so I've installed 6 point motors, including the 2 for the freeway point. They are wired no differently at the moment. So they're all in, the orientation of each one is good and they're nicely centered. So I'll just need to wire them up to the bus wires and the switches. Okay, I've completely wired up one of the motors. I'm just doing the last little bit. I'll go over all of the connections again briefly in a moment. But first, remember the 2 wires that for your switch. Well, they come down here. There they are, so they need to go to my switch. The last wire that you need to do is this one up here. This is another red wire, and what that does is go to the middle of the switch on the 3 terminals. So that goes to the middle of the switch and gives the switch power, and that needs to run to the positive of my 12 volt DC supply that I've got up here. So there we go, soldered up. Middle one goes to power from my DC supply. The two outer ones go to either side of the motor. So if I flick the switch, it should operate the point motor. So there we go, that point is now working. And there is something else you can do if you want to. You can rig up something called a capacitor discharge unit, and what that does is it stores up a load of energy and then releases it when you flick the switch, and it releases it very quickly. So you just send a momentary burst of power to the point motor, and that will quieten them down a little bit and stop the vibration noise that you hear when they operate. Something I may implement in future, but for now I'm just going to try and keep things a little bit simpler and just go with it as it is for now. But it's something I might do in the future. Okay, so let's just double check the wiring. So on the left hand side is the red wire, goes to our switch, which we know about. Right hand side is the other wire to the switch, goes the same way. The green one goes to the frog. See, that runs over here and then joins onto that wire on the bottom of the motor, the bottom of the point, sorry. The two blue wires are DCC dropper wires to run the polarity switch. They come down here, go into the DCC power bus. The black one is an earth. Follow that. And that goes into the blue wire here, which is the earth or the negative of the DC power bus. Okay, now I'm just going to fully test that we are getting power sent to the frog from the point motor. So what I'm going to do is take a piece of paper. What you can do is wedge it between the two rails just there, and then if I flick the motor, there we go. So now I've flicked the motor and we are as if we're going straight rather than turning left. By putting the piece of paper in there, I'm eliminating any continuity between the two rails here. So the only way it's going to get electricity is from the actual point motor's polarity switch. So let's put a multimeter on there, and you can see on the multimeter we're getting 15 volts across those two rails, which means that power is being sent to the frog from the motor. Okay, I've just flicked the motor over to the other way, so we're now as if we're turning left. So the polarity switch should be sending plus to the frog now. Put a multimeter on it, and again you can see 15 volts is showing there. Right, so it's now time to turn my attention to the three-way point and get all this wired up and working. Now at the moment this entire area here is dead. You can see the insulators for it there. So at the moment this whole area is dead, and as a result everything stalls trying to go across it. So we'll certainly know if we've wired it correctly, because if anything stalls it's not working, and if it goes across then we've done it right. Now it can look a little bit daunting, but in reality it really isn't. It's actually quite simple to wire up. As always, Pico give you some decent instructions, and on the back you can see the wiring diagram. Now it's relatively simple. All we do is treat it as two separate points. So we have a point motor on that tie bar, point motor on that tie bar, and we have two frogs. Got one there, and as a result there are two wires dangling out the bottom. One wire goes to one point motor, the one that does the switching between straight ahead and left, and the other frog is wired to that one, which does straight ahead and turning right. Everything else about wiring the point motors is normal. You just have to make sure that the right motor is wired to the right frog, and then everything should work as intended. So I'll go over it just very briefly again. So the one that does straight ahead and left deals with the frog on the left hand side. The one that deals with right and also straight ahead, that's this longer one here. That's right, that's straight ahead. That one deals with the frog on the right hand side. As long as you get those wired to the right point motor, everything else is the same as before. Okay, so I've wired it up. We'll take a look at the wiring in a second. I'm just going to check it works. The motors are wired so that they work with the switches. Other one works as well. So what I'm going to do is I'm going to very slowly creep the 08 shunter onto the frog area and see if there are any problems. If it's wired up incorrectly, it would have shorted out already, I expect. But if something's managed to slip through the net, what will happen is as the loco comes onto the point, it'll short out anyway if there is an issue. But I think it'll be fine because you know, I've turned the layout power on and nothing bad has happened. So let's see what happens. Okay, so let's bring the 08 on. It's a good sign. Seems to be working. Let's try really slowly. Yeah, that's working great. And you can't quite see it, but on the point there is an isolating section just there, and we've also got the insulating fish plates just here, so this entire section is all powered by the polarity switch on the point. But obviously that only proves that that particular section works. I'll need to check the track closer to us. So it seems to be working okay. Okay, so there's the wiring for the two motors. They're both wired basically the same. They're wired as per a normal point motor. I did have to flip one of them around so the wires would clear. But we just have our droppers wired the same as before. The DCC droppers, the one further away from this side of the table goes to positive. The one closer to this side of the table goes to negative, as per all the other point motors. You can see the feeds in there. The only difference, because it's a three-way point, is the frog. So the frog wire from the point further away from us goes this way into the feed for the frog, goes to the frog on the left hand side, and then the point motor closer to us, so that one, frog from that one, goes the same way, and then that goes to the frog on the right hand side. So they are wired as traditional ordinary point motors. You just have to make sure the right one is connected to the right frog. And for this particular Pico point, this one goes to the frog on the right hand side, this one goes to the frog on the left hand side. That's all you need to remember. So as you can see, the wiring does get a little bit complicated, and it all needs tidying up, so I tend to use tie wraps, and I'll try and bundle the cables in groups. If they all go to the same place, I'll try and bundle them together. And I also try and do things like use the same connector for multiple wires, but it will need a bit of a tidy up. Plus I've got these red ones that are just dangling. These are all for the switches. They will route this way and go up to a control panel, which I'll be building in a future video. But for now, I just need to get the rest of them all wired in, and then I can tidy up all the cabling and can move on to the next thing. So there you go, hope that was helpful. So we've now got locomotives running, and the points are now starting to take shape. Some of them are now completely finished and working on the switches. Others are wired up, but they are still at the moment a manual operation. So I'll go away and I'll get the rest of them wired up and all connected to the switches, and then we can move on to the next stage.